part of Earth seems to have preserved its appearance from a very distant past, while many other regions have continued to change. On ancient plateaus, prolonged isolation allowed many species to survive without appearing anywhere else. From the edges of those cliffs, streams of water plunge nearly 1 kilometer before dissolving into mist. But Venezuela was not shaped by tepuis alone. Offshore lies the Caribbean Sea, with white sand islands and coral reefs, while to the west rise the Andes, where ice exists close to the equator. Why do so many forces of nature converge on the same land? Begins with enormous sandstone formations that have remained almost unchanged throughout the geological history of this region. Some regions on Earth have been isolated for so long that life above them evolved along its own path for millions of years. Many plant and animal species existed only on those summits, with almost no opportunity to spread down to the lowlands below. The Pemen call these mountain formations Tepui, meaning house of the gods. According to their beliefs, this is where the Mawari spirits reside. Tepuis appear in Venezuela, Guyana, and Brazil. But most of this system is concentrated in southern Venezuela, across the Guiana Shield, one of the oldest surviving rock formations on Earth. Their flat summits and nearly vertical cliffs were not formed by volcanic activity. They are the remaining fragments of an enormous sandstone plateau formed more than 1.5 billion years ago, when life on the planet still existed only in its simplest forms. Over hundreds of millions of years, wind, rain, and river networks continuously eroded the softer layers of rock, while quartz-rich sandstone formations remained standing against the process of erosion. This terrain gradually separated each summit from the rest of the plateau. Vertical distances reaching thousands of feet made it nearly impossible for many species to move between the summit and the base. Prolonged isolation formed separate ecosystems, where many species of carnivorous plants, frogs, reptiles, and small organisms exist only on individual tepuis. Among hundreds of tepuis, one mountain became the symbol of this entire region. It is Mount Roraima. Rising about 9,200 feet above sea level. Its summit plateau covers nearly 12 square miles and is surrounded by cliffs reaching up to 3,000 feet. Its almost isolated terrain and heavy rainfall cause clouds to frequently cover the entire summit. To European explorers in the 19th century, Roraima appeared to be an almost inaccessible world. That image inspired Arthur Conan Doyle to create the setting for The Lost World. But Roraima preserves more than an ancient world on its summit. Every rainfall across the plateau begins a new journey. Water moves through cracks in the rock, joins into small streams, and then plunges over the cliff edge. One of these streams forms the highest waterfall in the world. The highest river in the world does not flow across a plain. It ends directly at the edge of a plateau. That is the moment when the Churun River leaves Tepui and becomes Angel Falls, a waterfall approximately 3,200 feet high. The first nearly 2,600 feet form a free fall, long enough for the water to separate almost completely from the cliff before reaching the forest below. The water feeding Angel Falls does not come from an enormous lake on the summit. Rain falls continuously across the flat surface of the Tepui, filters through the ancient sandstone, and gathers into small streams. They join to form the Churun River, quietly crossing the plateau for many miles before suddenly ending at the cliff edge. This terrain transforms an ordinary river into the highest waterfall in the world. The flow of Angel Falls changes with each season. When prolonged rains cover the Tepui region, the entire waterfall appears like a white ribbon stretching from the top of the plateau to the base of the mountain. But during the dry season, a very different phenomenon appears. Across a drop of nearly 1 kilometer, powerful winds continuously tear the water into millions of droplets. On some days, most of the water leaving the edge of the Tepui never reaches the ground. It dissolves into the air during the fall, leaving the entire waterfall resembling a cloud suspended beside the cliff. Humans learned about this place only relatively recently. In 1937, pilot Jimmy Angel landed on the summit of Tepui. During a flight in search of gold, his aircraft became trapped on the plateau, forcing him and his companions to walk for several days before returning. That event placed Angel Falls on the world map. Although the water had been silently falling into this forest long before the name existed. After a drop of nearly 3,200 feet, the journey of the water is still not over. flows along the Churun River. The river's dark brown color comes from organic compounds carried by rainwater through the dense vegetation of the tropical forest. For many years, this was almost the only route to Angel Falls. Canoes traveled upstream through narrow river corridors, while the cliffs of Aoyan Tepui gradually became clearer ahead. Farther downstream, the Churun joins the Karau River and then spreads across a low-lying area of the ancient sandstone foundation to form Canaima Lagoon. Behind the curtain of water at Sapo Falls, the current has hollowed out the base of the cliff over thousands of years, leaving a natural passage directly behind the waterfall. Even after leaving the mountains, its influence has not ended. A single river cannot transform an entire region, and the Caroni has never been a solitary river. The river begins near the Brazilian border, then receives water from countless tributaries flowing down from the tepuis before traveling more than 950 kilometers to join the Orinoco. The dark color of the Caroni does not come from sediment, but from organic compounds carried by rainwater through tropical forests and ancient rock layers. With each rainy season, the Caroni carries material eroded from the plateau and deposits it across the lowlands. That process continues, gradually expanding the lower floodplain. But the Caroni is still not the final destination. When it joins the Orinoco, it becomes part of the third largest river system in South America. The water continues eastward, gradually slows, and spreads into a delta covering more than 39,000 square kilometers before reaching the Atlantic Ocean. A drop of water falling on a tepui can eventually become part of the ocean. Almost all of southern Venezuela is connected by the same enormous water system, which had been operating long before humans appeared. That system also determines where life can survive. As water levels change with the seasons, flooded grasslands expand and contract. Herds of capybaras move with their food sources, while jaguars silently follow the same routes in search of prey. Humans have also adapted to the same pattern. The Waro settled throughout the delta centuries ago. Their name means people of the dugout canoe, because in this region, rivers are the roads, houses raised on stilts, dugout canoes, and the way they travel between river channels, all developed around the rising and falling rhythm of the water. Places where life gathers also become the places where hunting begins. Jaguars do not need to search across the entire forest. They move along river routes, waiting beside the water where prey is forced to appear. Flood season and dry season only change the location of the hunt. The pattern remains almost unchanged because water continues to determine every movement within the ecosystem. From the Tepui summits to the river mouths facing the Atlantic Ocean, all of southern Venezuela operates within the same natural cycle. But not all of that water flows into the sea. Some of it quietly seeps into ancient rock formations, disappears beneath the ground for a very long time, and later reappears in another world. A stream of water can carve through an entire mountain without an earthquake or volcanic activity. As limestone gradually dissolves under the influence of rainwater, rich in carbonic acid, small openings widen into tunnels and eventually develop into an underground world extending for kilometers. Venezuela still preserves one of the clearest examples of this process. Over a very long period, groundwater continued to enlarge these tunnels. As a result, Cueva del Guacharo now extends for more than 10 kilometers with vast chambers and underground streams that continue to expand its internal structure. In 1799, naturalist Alexander von Humboldt became the first person to introduce this cave to the international scientific community after his famous expedition through South America. But the structure of the cave explains only half of what exists here. Thousands of Guacharo birds live in the darkness throughout the year. They are among the very few bird species in the world that use echolocation to move through caves, following a mechanism similar to that used by bats. Every night, they fly into the forest in search of food, and then disperse seeds across a vast area, connecting the underground ecosystem with the forest outside. Those ancient rock layers do not end beneath the ground. Their traces also appear along the Caribbean coast, where an arid climate has driven the same geological foundation in a completely different direction. On the Araya Peninsula, low rainfall and high evaporation concentrate seawater in shallow lagoons, leaving layers of salt that accumulate over time. Then this seemingly ordinary material became the cause of a conflict lasting for decades. During the 17th century, Salt was an essential resource for preserving food during long sea voyages. Dutch merchants repeatedly extracted salt from Araya, forcing Spain to build a fortress in 1623 to maintain control of the peninsula. Off the coast of Araya, the same waters concealed a resource more valuable than salt. Warm water and shallow seabeds around Margarita Island once supported large populations of pearl oysters. When Christopher Columbus reached these waters in 1498, pearls quickly brought the island into Spain's extraction network. From that point, Margarita developed into a maritime hub where marine resources determined the pace of settlement and the expansion of trade along northern Venezuela. The safest places for ships to shelter often appear along the most rugged stretches of coastline. Along Venezuela's Caribbean coast, tectonic movements raised mountain ranges close to the water's edge. Over millions of years, waves and ocean currents eroded the rock formations, dividing the coast into countless naturally protected bays. The water inside remains calmer than offshore, providing safe anchorages without the need to build artificial harbors. Coastal communities gradually developed around these waters. Mochima clearly reflects this process. The national park was established in 1973, protecting more than 940 kilometers of sea and land. Where mountain slopes descend directly into the water, the sheltered terrain helps maintain fishery resources, while the locations of villages, anchorages, and the fishing schedules of local communities all developed according to the natural structure of the coastline. As maritime activity expanded, the enclosed bays no longer served fishing alone. They became the foundation for the development of coastal cities. Lecheria was planned across a tidal lagoon, instead of filling in the water. The city developed alongside a network of canals and marinas, maintaining natural water flow between residential areas and connecting directly with maritime trade. The increasing volume of shipping also changed the role of the coast. Bay entrances that once provided safe shelter gradually became control points along maritime routes. El Morro stands directly at the entrance to Barcelona Bay, where every ship entering or leaving must pass. From the early 17th century, the Spanish built a fortress here to protect Caribbean trade routes from pirates and rival fleets. The importance of El Morro was never determined by the size of the structure. The terrain at the bay entrance concentrated all shipping traffic through a single point. transforming a place that once sheltered vessels from rough seas into a strategic gateway to the entire Caribbean region. Only a few kilometers from the Caribbean Sea. One place became the capital of an entire country. Another remained almost isolated from the outside world for decades. And another valley became famous for its cacao beans. All of them began with the same mountain range. Across many geological periods, tectonic movements raised the Cordillera de la Costa along Venezuela's northern coast. This mountain range separates the coastal zone from the valleys behind it, where water supplies are more stable and the terrain is more suitable for permanent settlement. A single geological barrier caused each valley to develop in a completely different direction. Caracas is the clearest example. In 1567, the Spanish founded Santiago de León de Caracas in a valley surrounded by mountains. The city maintained connections with ports on the coast, but its terrain helped protect it from many direct attacks from the sea. Over several centuries, Caracas gradually became the administrative center of the colony and continued to serve as the capital after Venezuela gained independence. By the 20th century, oil changed everything. People from across Venezuela continuously moved to the capital, while the flat land within the valley was rapidly filled. Only the terrain remained unchanged. As available land gradually disappeared, Caracas began climbing the surrounding mountain slopes. Barrios appeared one after another, while the valley retained the limits that nature had established millions of years earlier. Immediately north of the capital, El Avila still stands as a natural wall rising more than 2,700 meters for more than 4 centuries. This mountain range has continued to separate Caracas from the Caribbean Sea and preserve the geographical limits to which the city has always had to adapt. But not every valley behind the Cordillera de la Costa became an urban center. In 1843, a group of immigrants from the German region of Baden settled in Colonia Tovar, when the mountain roads were still extremely difficult to cross. This community remained almost isolated from the rest of Venezuela for decades. Its language, architecture, daily customs, and farming methods were preserved across generations, as though life there moved more slowly than in the rest of the country. Farther west, another valley followed its own path. In Chihuahua, water from the Cordillera de la Costa combined with a hot and humid climate to maintain ideal conditions for cacao trees from the colonial period onward for centuries. Traveling by sea remained easier than crossing the mountains behind the valley, helping preserve traditional methods of cacao cultivation and processing. This made Chihuahua one of the most renowned cacao-producing regions in Venezuela. Can an island be built by billions of tiny organisms? In the Caribbean Sea. The answer existed long before humans reached the northern coast of Venezuela. Each coral polyp leaves behind only a very thin layer of limestone after it dies. Over many years, countless layers of this rock accumulated, gradually raising the coral reefs closer to the surface. As sea levels changed over time, parts of the reefs emerged and became low-lying islands in the ocean. Los Roques is the clearest result of this process. The archipelago consists of more than 300 islands, sandbanks, and coral cays, with almost all of its land formed from coral and limestone. In 1972, Venezuela established a national park to protect one of the most intact coral reef systems in the Caribbean. Yet this same place, so rich in life, also imposes a major limitation. The islands rise only a few meters above sea level. There are no rivers, no natural lakes, and fresh water is always extremely scarce. The conditions that allow coral to thrive also make it difficult for humans to sustain permanent life. For centuries, most of the archipelago remained almost entirely under the influence of the sea. But coral reefs do more than build islands. They also reduce the force of waves before the water reaches the shore. In Morocco, waves lose much of their energy after passing over the offshore coral reefs. The calm waters farther inland allow mangrove forests to develop, trapping mud and sand and providing a place where many marine species begin their life cycles before returning to the reefs offshore. These two ecosystems have never existed separately. They are part of the process through which nature has shaped Venezuela's northern coast over thousands of years. But the nature of this country was not shaped only at sea level. One of the largest oil basins in South America lies directly beneath the sky, illuminated by lightning on hundreds of nights each year. Both converge around Lake Maracaibo. For tens of millions of years, the Maracaibo Basin continuously subsided and received enormous amounts of sediment from the rivers flowing into it. Layers of organic material were gradually buried deep beneath the lake bed, increasing pressure and temperature, transformed them into oil and natural gas, forming one of the largest oil basins in South America. At the beginning of the 20th century, enormous oil fields were discovered one after another. Thousands of drilling platforms appeared across the water. In 1962, the General Rafael Urdaneta Bridge, more than 8-kilometer long, was completed to connect the two sides of the lake with offshore extraction areas. From that point, Maracaibo became the center of Venezuela's oil and gas industry for decades. Directly above the lake, another natural mechanism continues without interruption. Hot, humid air rises from the vast body of water and meets cold air masses descending from the Andes. The almost enclosed terrain surrounding the basin maintains powerful convection currents, causing electrical storms to form repeatedly near the mouth of the Catatumbo River. At times, dozens of lightning strikes appear within a single minute and continue for several hours. This phenomenon occurs on hundreds of nights each year, making the sky above Lake Maracaibo one of the places with the highest lightning density on the planet. Farther east, Venezuela's terrain changes again. This time, wind becomes the force that shapes the land. Sand dunes more than 40 meters high continue to drift silently just a few kilometers from the Caribbean Sea, in the tropics, where rainfall usually sustains dense rainforests. Northern Venezuela instead contains a sandy expanse covering nearly 900 kilometers that is constantly reshaped by the wind. The answer does not lie on the land. It begins in the waters off the coast of Falcón State. Cold water rising from the ocean lowers sea surface temperatures and reduces the amount of moisture evaporating into the atmosphere. At the same time, the Sierra de San Luis traps most of the moisture coming from inland before it can cross the coastal region. As a result, annual rainfall drops below 250 millimeters, enough to maintain an arid climate directly along the Caribbean coast. From that point, the trade winds become the force that continuously shapes this landscape. Layer after layer of sand is carried inland from the coast, with no extensive vegetation to hold it in place. The dunes are constantly eroded and deposited somewhere else. Médanos de Coro almost never keeps the same shape for very long. Footprints left in the sand quickly disappear, and even an entire dune can change after each windy season. People continue to adapt to this land. near Barquisimeto. The Monumento Manto de Maria di Divina Pastora, inaugurated in 2016, stands as a new landmark in this semi-arid region, where daily life continues alongside a landscape that is constantly changing. While structures on the ground remain almost unchanged through the years, the wind steadily rewrites the appearance of Médanos de Coro. Each gust carries more sand inland from the sea. Every dry season erases old traces and builds new dune ridges, ensuring that this desert never truly stands still. Venezuela shows that nature has never operated according to a single rule across the same land: geological, climatic, and biological processes unfold at very different rates. Some places remain almost unchanged for an extremely long time, while others continue to transform before our eyes. Each place, therefore, offers another perspective on how Earth has been formed, transformed, and has sustained life through time. If you enjoy documentaries like this, subscribe to the channel and join us on future journeys. There are still many places on Earth waiting to be discovered,